Welcome to our video on networking in Google Cloud. Today, we'll explore the basics of Virtual Private Cloud, VPC, and how it works in Google Cloud Platform. Think of Google Cloud as a large office building. Inside this building, there are many departments, each representing a VPC network. These VPC networks are isolated from each other, ensuring security and privacy. The VPC network in Google Cloud is a virtual version of a physical network. It provides connectivity for Compute Engine VMs, supports internal network load balancers and application load balancers, connects to on-premises networks via Cloud VPN and Cloud Interconnect, and distributes traffic from external load balancers. Each project can have multiple VPC networks. By default, new projects start with an auto mode VPC network, which includes one subnetwork in each region unless restricted by an organizational policy. Each department controls who enters and exits using Firewall Rules. These rules manage the traffic coming into and going out of the VPC network, keeping it secure. VPC firewall rules in Google Cloud apply to a specific project and network. To apply rules across multiple VPC networks, refer to firewall policies. VPC firewall rules control connections to or from VM instances within your network. These rules are always enforced, protecting instances regardless of their state or configuration. Each VPC network acts as a distributed firewall, defining rules at the network level but applying them on a per-instance basis. This setup secures connections between instances and other networks, as well as between instances within the same network. A VPC network is like a department in the building, connected by hallways, which represent the global network. Inside each department, there are rooms, called subnets, where specific tasks are carried out. VPC networks in Google Cloud are global resources composed of regional subnets with specific IP address ranges. Subnet and subnetwork are synonymous. Auto mode VPC networks automatically create subnets in every region, while custom mode networks start with no subnets, allowing full control over subnet creation. When creating resources, you select a network and subnet, which must be in the same region as the resource. This applies to VMs, managed instance groups, and Kubernetes clusters. Each subnet is a regional resource, meaning it exists in a specific geographical area, and it defines a range of IP addresses using CDR blocks. Block all traffic by default and only allow the specific traffic you need. This includes limiting the rule to just the protocols and ports you need. Use hierarchical firewall policy rules to block traffic that should never be allowed at an organization or folder level. For allow rules, restrict them to specific VMs by specifying the service account of the VMs. You can use service accounts or network tags to apply specific firewall rules. Identity in Google Cloud is not based solely on the subnet IP address. Ensure that firewall rule allow the right kind of traffic. Only allow traffic from load balancing into VM instances. Allows health checks from load balancing to VM instances. All egress from a VM instance is allowed by default. To allow specific egress. 1. Create an egress rule with low priority to deny traffic. 2. Create egress rule with high priority to allow traffic on specific port. With Shared VPC, multiple projects within the same organization can share a VPC network. This allows different teams to manage their resources independently while using a common network, improving collaboration and resource management. Let's imagine you have an organization with multiple departments. Your IT department needs to access other departments' resources such as marketing, finance, development. Your IT team manages all the network resources centrally, ensuring consistent security policies and IP address management. Each department's resources should be isolated within their service projects, but can communicate securely using internal IPs. Each department can track its usage and costs independently while sharing network infrastructure. A shared VPC network is created in the host project. Subnets are created for different regions to be used by the service projects. Each service project is attached to the shared VPC network from the host project. Departments manage their resources, VMs, databases, within their own projects, but use the shared VPC network for connectivity. Shared VPC in Google Cloud allows multiple projects to connect to a common VPC network for secure, efficient communication using internal IP addresses. A host project with shared VPC networks is designated, and service projects are attached. This setup centralizes network control while delegating resource management to service project admins. It supports least privilege security, consistent access control, and budget separation across projects. Shared VPC admins control network resources, while service project admins manage instances using approved subnets. A shared VPC network is defined in a host project and shared with service projects for centralized networking. It supports auto or custom mode VPC networks but not legacy networks. You can share all subnets in the host project, including new ones, or specify individual subnets to share. Host and service projects are linked at the project level, allowing service project admins access to the subnets in the shared VPC network. VPC peering allows VPC networks to communicate with each other as if they were on the same network, even if they are in different projects or organizations. This setup maintains network isolation while enabling secure communication between resources. VPC network. Peering connects two VPC networks for resource communication across the same or different projects and organizations. It supports SaaS offerings, Compute Engine, GKE, and App Engine. Peering allows internal IPv4, IPv6 connectivity with the same performance as within a single VPC network. It does not support transitive routing or auto mode VPC connections. Peering exchanges routes between networks but keeps them administratively separate. Each network's administrator must configure and manage their side of the peering connection. Thanks for watching. Please make sure to like and subscribe to support my journey.